Video made by Math
Hello, welcome back to
Clinic.
my channel, Math Clinic. So let's solve this. So we have these sets. So before we include those values, input those values into this set, let me explain these numbers here. So we have this natural number here. What is a natural number? Let's explain. Natural number is they are positive whole numbers, excluding zeros. Okay, that's positive and whole numbers. So let's go to integer. Integer, they are negative and positive whole numbers, including zero. Then after that, let's move to rational number. Rational numbers are numbers, they are fractions, recurring decimals, terminating decimals, whole numbers, positive and negative whole numbers, including zeros. Now let's go to real numbers. Real numbers are fractions, terminating decimals, recurring decimals, whole numbers, positive and negative whole numbers. Then we have not non-perfect square numbers, square roots of, for example, square root of 2, those are not perfect square. Square root of -9, those are not perfect square. Those are real numbers, including constants. Constants, they are also real numbers. Even complex number, because these are complex numbers here. These are complex numbers here. This is a complex number because we have square root of minus, maybe -9 or -1. It's a complex number. So a complex number is also a real numbers. Okay. Now let's move on to what we are asked to do. We are asked to put in those numbers here into the sets. So we're going to explain here. That means integer accumulate natural numbers. Rational numbers accumulate both integers and natural numbers. Then real numbers accumulate rational numbers, integers, and natural numbers. So let's impute those things into the set. So let's do that. So the first thing to do, let's go to natural numbers. Those are positive whole numbers, excluding zeros. So look at whole numbers here. Is this a whole number? No. What about this? Yes. This is a perfect square because square root of 25 is 5. So it's part of it. I'm going to write it here. So I have square root of 25. Square root of 25 is part of it, isn't it? So when I'm done writing it, I'm going to strike it. So let's move on to the next one. Let's move on to the next one. So this, no. Negative. This, recurring, no. What about this? Yes. Let's look at this. This is also a whole number and it's positive whole number. 36 over 9 is 4. So it's part of the natural number. So I'm picking it, I'm going to strike it. So I'm going to write it here. So that is 36 over 9. So I'm done. Then move on to the next one. Integers. Look at integers. Negative. We have picked the positive number because it accumulates natural number. So we're going to pick the negative whole number. So look at this. Cube root of -27 is -3. So that is part of the what? The integer. So we're going to write it here. So 3 cube roots of -27, and that's all. That's all. I'm going to strike it after putting it down. Then let's move on to the next one. So let's go to rational numbers. I told you rational numbers are decimals, terminating and recurring decimals, including fractions. Okay. Now let's look at this. 5.6 is a terminating decimal, isn't it? So I'm going to put it down here. So 5.6 is part of it. Now we have recurring decimal also. 2.345 recurring. 2.345 is also a recurring decimal and is a rational numbers. So are we done? No. Let's look at this. We see that 35% is also a fraction. 35% means 35 over 100. And when you divide that by 5, you have 7 over 20. Isn't it? If you divide that, you have 7, and it's a fraction. So percentage is also a fraction. You get me? So we're going to put it down here. So we have 35%, which is what? A rational number. Now let's look at the next one. The next one we look at is what? Real number. So we have picked this one, I'm going to strike it. We have picked this one, I'm going to strike it. We have picked this one, I'm going to strike it, please. Now let's move to the next one. So we have real numbers. I told you real numbers are non-perfect square, also complex number and a constant. So we have this constant here, 2 pi over 9. 2 pi over 9 is a constant. We have pi here, and it's a real number. Okay, so we're going to input it out. So we're going to put it here into the set. So we have 2 pi over 9, and that is all for now. So we've seen that this accumulate all the side set. So this is for this is for this is for this, while this is for this. And that is all we have for now. So thank you and God bless.